Thank you, Lisa. So Hyatt Group was established in 1937. In 1986, they went into consumer business and later on also to hygienic. 2006, as we can see, they started their first tissue machine. And already this year, they will start their number 9 machine, giving Hyatt a production of 630,000 tons yearly. But today, we will look at some of the technology Hyatt has and how it influences sustainability, with focus on CO2. So Kemal, can you please describe the start of the tissue journey for you?
Hello, everyone. For our first tissue machine, we were looking to invest in long-term smart solution. One key idea was to have a full cogen operation with the tissue machine.
Let's have a look at what that means. So on this graph, we see CO2 on y-axis and production on x-axis, where we introduced TM1 and when TM1 started cogeneration.
Yeah, with the cogen technology, we can drastically reduce the CO2 footprint. Of course, it depends on the local energy system you have available, but at our case, the reduction is about 32%, as you can see on the graph.
Yeah, and with the system that Hyatt had from the beginning, we have done some rebuilds of that to improve the system integration, to improve the efficiency. And that's when we can have these numbers we're seeing. So with the Valmet setup, we introduce gas into the gas turbine, producing electricity for the mill. But also the exhaust gases are used in the drying with the Yankee hood and also to produce steam. So all the drying that is needed is coming from the gas turbine exhausts, giving us example here, where we have CO2 emissions of 440 kilograms of CO2 per ton produced paper with cogeneration. But if we don't have cogeneration, we have to consider the CO2 density of the electrical and the gas and the steam individually, giving us 658 kilograms of CO2 instead. But Kemal, you also had other opportunities with your cogeneration.
Yes, when we did the investment, we installed a 15 megawatt turbine system. So we were producing more than needed electricity and using the exhaust of turbine for paper drying and producing 15 bar steam, as we explained. But with this size of turbines, we have excess energy. And this excess energy is used for heating or cooling for, by 4 bar steam chiller, depending on the season. We can reach more than 80% of energy efficiency with this cogeneration configuration.
And for next machine investment, you look to get 2 new machines, and this time you changed supplier to Valmet.
Yes, this is correct, and our focus has shifted to lower basis weight products, and we still want to have a high production level. At this level was required a high-speed machine with reliable and high efficiency at speed of 2,100 meters per minute. And we believed Valmet machine can run high speed and high efficiency. Both machines proved that in very short time period. We even had the world speed record of 2,210 meters per minute for TM2 machine.
Yes, so definitely impressive. For coming machines from TM4 to TM9, you changed the pressing technology and went for ViscoNip. How were your thoughts for the ViscoNip back when you invested for TM4?
Yes, well, the focus on the energy has increased, and to get this wide range of flexibility, we were really interested on the ViscoNip technology. We also, we had high expectation on the unique design of loading element in terms of runnability improvement. We then also decided to rebuild TM1 with the ViscoNip.
So let's again look at this graph where we now have ViscoNip comparing to the base of TM1 where we have suction pressure roll. So the delta is about 12%. But at Valmet, we always want to improve, and we want to be able to improve together with our customers. So for TM7 for Hyatt, we were able to offer a new generation of loading element to the ViscoNip, increasing press dryness and then reducing CO2 emissions. So as we can see on this graph, that adding the new generation ViscoNip, reducing the CO2 by another 3%, overall about 15% reduction in CO2.
Yes, with new generation ViscoNip loading element, we achieved about 1 to 1.5% unit more dryness at the Yankee, even as a total improvement of 6 to 65% unit dryness compared to TM1 original suction press roll. The new generation loading element was also applicable to existing ones. We decided to upgrade the machine in operation with the new generation ones.
It's evident that cogeneration and machine technology can really affect the CO2 and reduce the emissions. But it's also important how we combine it with the tissue machine to efficient tissue production to get the good benefits. And we have an example of this from Hyatt, a machine, and looking at the startup period and some years in production at a greenfield mill at Hyatt.
Yes, in this graph you can see efficiency and production at TM5 Mersin project. We have reached these values with 2-3 experienced foremen and no experienced manpower. We also made mostly jumbo roll products at the beginning, means no stable production. Another issue in this graph is that the basis weight is getting lower and lower, more than 2 grams at average. But we keep the efficiency and production at high level.
Yeah, and for us at Valmet, to work together with a company like Hyatt, we can easily find common ground in the importance of high production at high efficiencies. And the backbone of this being stability. Stability that you can achieve throughout the machine with good basis weight profile and moisture profile, among other important factors. And with this, you can push your speed upwards and maintaining a good efficiency. And also getting a good end product and predictable end product. So as we see, good numbers, but how have the short term been, just the startup periods?
Yeah, at TM7, we accomplished very fast startup curve, as you can see. We have reached over 1900 meter per minute speed in 3 weeks. And later in 9 weeks, we have reached full speed production at 2100 meters per minute. The time efficiency was 91% first year, and also we have reached 63,000 tons of production in 11 months.
Yeah, so impressive again. And with these high production speeds early on to good startup efficiencies, it also impacts the CO2 significantly. As 1% improvement here would reduce the CO2 by 300 or 460 kilotons of CO2 yearly, using the 2 examples we looked at earlier. So let us now combine all of Hyatt's machinery and look at this graph, where we can see that the CO2 is reduced with 28% comparing to the base of TM1. So with the new investments, the new machines coming along from Hyatt, they reduce the CO2 every time. But also going back and working with their existing machines, changing like the rebuilds of the ViscoNip that Kemal explained, but also like vacuum systems.
Yes, it's truly shown that technology we have create a major reduction of CO2 emission.
Yeah, and for us at Valmet and with Valmet technology, we can really offer, and with Valmet experience, we can really offer you, the producers, the chance to reduce and impact your CO2. And depending on the local energy and the CO density of that local energy, the CO2 can be reduced even further. With that, we thank you for listening to us, and we will be available for questions in the Q&A. Thank you.